Hey Ingo, welcome back.
Hi Adam, how are you doing?
Perfect, really. Just cranking Java code. There was no opportunity to profile because it works good enough. But yeah, but I thought the entire time about no kidding, not maybe not the entire time. From time to time about JVMPI and TI, right? These are
Right.
the two APIs. And what you told me right the last time is that the PI was the older one and the TI was the newer one, right?
Yes, that's correct. The TI is actually also for the debugger, so that combines both the main tools, which need a native interface to the JVM to get things done.
I took a brief look at the TI because the PI is harder to find, and it is like provides a C-like library, sorry API to instrument to actually manipulate the JVM, right? So this is what the TI is.
Yeah, that's correct. It's for the native agent. So that has always been like also in the JVMPI that was a native interface because the profiler had to be written in C and not in Java. Like today, we of course also have the Java agents to do stuff, so it's more mixed. But still, like if you want to write a profiler, you have to use the JVMTI, so you have to write a native library.
Everyone has to do it, right?
Yes.
You know whether the async profile is also doing it? You know the open source async profiler?
Yeah, I mean also a native interface. Actually, the async profiling uses the an undocumented method in the hotspot JVM to get stack traces
Okay.
without pausing all the threads, and it has to do that on a signal handler. So it is not something that you can just call from any thread. You have to call it on a signal handler, and that is typically only possible on Linux and Mac OS. And on Windows, it's a lot harder to do that. But that's also a native interface that you have to write a native agent for.
So it means there can be no, a pure Java profilers, right? Every profiler will have to access the JNI in one A or another.
No, I mean you can use a Java agent to do profiling. I mean, also it's what does profiling mean? It means just gathering some information about the runtime characteristics and presenting it to the user so the user can find out what the problems are. And
Yeah, you can use either Java agent or TI. This is what basically it. Because for instance, I think Bitrace is Java agent based. It's just it's just like this is like a profiler toolkit. It's not even a profiler, so you can manipulate the bytecode like a dtrace. So you can use the Java agent for it, or if you would like to use or create a true profiler, so debuggers, you will have to use the JVMTI, right? So I think.
well, it's just a matter of overhead, really. I mean, you can write a Java agent and then get the stack traces from all the threads that are running in the JVM. That is possible. And then you can like build a call tree and make hotspots and so on. So you can write a profiler just with a Java agent, no problem. But you will have big overhead and will distort the runtime characteristics. And
Exactly.
then you can have the JVMTI, which is the native interface where you have lower overhead and the JVM cooperates with your request to do things. That's
Okay, this is where I'm going. So first, maybe before we start, really, you know why PI was discontinued, or I don't know whether it's even discontinued, and TI replaced PI. So where the limitations were back then?
there were things in the PI that then were seen as not optimal. There were features in it that the JVM developers did not want to continue to have, so that had to be removed anyway.
Okay.
And there was ideas on how to unify the debugging and the profiling, so that was a step, and to also make it not experimental, something that you could rely on, which was not always in a state of flux like the JVMPI was. And that was a very, very good development because now there is lots of tests for it and it really works. And the JVMPI was something that was not as stable. And profiling used to be like something that was not very stable. So you profiled and the JVM had a certain probability to crash just like that, not because you were at fault, but just because the JVM did not expect to run in such a configuration. So those were the bad old times.
Okay.
Things are a lot better now.
So the JVMTI was never stable, right? It never reached stable API or whatever.
It was never seen as a stable interface.
Okay.
It
And the
was
JV,
always-
like the PI was like the unsafe, right? SunMISC unsafe, and the TI is a proper API to interact with the JVM. Can we see it this way?
Well, the PI was also documented, and they had it, but it was never tested really. It was never taken into account so much
Okay.
during the development of the JVM itself, as it is with the JVMTI. It's just now integral part of the JVM, and it's an important thing that the designers have to think about all the time. Like, for example, with virtual threads, when they developed that, this is a big problem to get JVMTI working also for them. But they need to do that all the time during the development process. So if they just forget about it, then profiling will not work anymore. So it has to be in the development process that the JVM developers think about this interface and write tests for it and try the new feature with JVMTI and so on. So that's very important.
I just the entire reference is in GNI or C. And for instance, I take a look right now on the heap, and there's a watched field, an object, and what is it? Ray monitor. And event management and stuff like that. So interesting. So actually, what would be fun, we could actually provide Java, right? Java API for the GNI. So you could actually write properly. You even did it with the JProfiler, right? So I assume you've wrapped the GNI native code with Java to make it a lot easier, right, to work with.
Well, I mean, our profiler has a large Java part and a large native part. So we try to stay in the native part, not go to the Java part when we can, because it's expensive to cross the boundary between native and Java. And there are lots of data sources that are in the Java part that need to then at some point travel into the native part, and we try to make that as cheap as possible. But we do not have logic in the Java part that uses native functions if we can avoid that.
I understand. Okay.
Because that's always, crossing the boundary is expensive.
This is like a hooks. So what I meant is just if you have no low-level GNI calls, you could actually wrap them with Java to make it more convenient. But the problem is if it calls you back, this is then the crossing the boundary too frequently wouldn't work. So what I thought about, if you just have, this JVMTI, we could write a nice Java wrapper to make the instrumentation easier. But if you also get data out of there, that sometimes maybe doesn't make sense to have, as you said, crossing the boundaries, because then it is too slow, right? So you have what I now understand, you have JVMTI, which produces the data, and the data is stored somewhere, and accessing the data from Java. And this is more or less, or not even asynchronously, but less frequently, you interact with the data sources, and this makes you more performant, right?
Right. And then the JProfiler UI attaches to a socket that talks to the native library, not to the Java part. So it gets all its data directly from the native library. So that's how it works in terms of getting.
Because if I see no native library, the first question I always ask myself, can we just have a Java interface for it, right? So what? So this is the first thing always, right?
You should do that, but with a profiler, it's really not possible. You have to push as much down to the native layer as you can.
Okay, so I now understood. So most of the performant profilers, how they are working, they write native code to interact with JVMTI. This is like the data producer. And there is a defined API, you said socket, and there is the visualization or presentation part. It doesn't have to be in visualize, it's like the UI part, which interacts somehow with the data sources and then sorts the data, filters the data, and does the more higher level operations, right?
Yeah, right. Yeah, that's a different types of profiler in the sense how they present the data. Like if you have this async profiler that is used quite a lot, they just have these flame graphs in HTML, and that's it basically. Yeah. With JProfiler, of course, there's lots of UI for the various features.
No, but the architecture is always similar, right? So we have the low-level, high-performance native part, and and the only reason why it is completely native is because the GNI interface, JVMTI interface, is called a lot. Maybe several times per second even. And if we do it via Java, JNI calls, this would be the overhead would be too high, because calling something several hundreds times per second between Java and JNI is just too slow. So you will remain. But the new how it's called, the new Java native access memories could actually, there could be a JVMTI 2.0 or 3.0, which will allow Java programs to access the memory natively, right? So this could help. The new JEP. This is called Project.
It's the Panama with all the various things to access memory and make native calls in a safer way. We have to see if it's going to be quicker, because it's going to be safer. So safer and quicker, we're going to see if that works out. But it's very promising, and it could be that it could make it easier. But there's always a problem in going from the safe space of the Java space to the unsafe space of the native, and there has to be some things happening in between. It cannot be so faster than using unsafe. That's for the memory access, for example. That is.
It's not possible, because in the name implies unsafe is fast, and whatever else would be safe. If something is safe, there should be a protection in place, and that protection costs time.
Yeah, that's it.
Exactly. Cool. So okay, this was actually a great point, because I always thought that you instrumented once and it stores the data somewhere, but it calls you back or whatever. This is very chatty JVMTI low-level API, right? So this is.
Yeah, absolutely. Oh.
Yeah, and it works. This is now about the sampling. And sampling profiler means that we are basically taking stack traces all the time, right? So the challenge is to point what you're interested in. You get the stack trace on event or something, and then you have to compare the stack traces. This is all about, more or less 20 years of refinement, but actually you are comparing for 20 years stack traces, right?
Yeah, the CPU profiling is about getting the stack traces in a manner that does not disturb the JVM too much. You have to disturb it maybe a little bit, like when you measure as a physicist, you disturb the system in some way. But we have to disturb it as little as possible, and it has to add as little overhead as possible. And the overhead thing was always a problem with sampling, because the sampling in the JVM, how do you get a stack trace from another thread that is running? It's you can imagine that this is super difficult if that thread is running, that you just ask the JVM, give me the stack trace. It could be in a process of changing frames and so on. So you have to sort of stop it in some way. You have to stop it and say, okay, now I can get the stack trace in a safe way of that thread.
Because you have one, let's say your application, you have 5 threads which are async. So what you would like to have is like a transaction, right? The exact snapshot. Give me everything you have right now. This is the challenge, right? You cannot go to the first thread and say, give me a stack trace, because they are no more comparable. What you would like to have in a profiler is like, now I would like to have all these stack traces. Is what I'm saying?
No, that's not the case, because in any case you're accumulating things. You're never looking at an instant in time, but you're always like looking at a longer time frame. So whether you get stack traces all at the same time or a little bit spread out over time is not important, because then you will anyway accumulate this stuff. Look at accumulated version for a period of time and say those are the hotspots that were in this time frame.
Okay,
that's not it. And the problem is that in the past you actually had to do it like you described. You had to stop everything and then say where are you now? And that was introduced a lot of overhead, of course, because you're stopping things and the JVM is not working anymore, and you have to then wait until all the threads are stopped. And they're stopped at some arbitrary locations where the JVM thinks, okay, I can stop here. So that's the problem. It has lots of overhead if you have very many threads, and they're not exactly in the situations where you would actually want to sample.
I confuse that with debugging, right? So if you are to debug, then it's more important to know, what's the status. But in profiling, you're right. This is like approximation, so you can gather and compare it afterwards. So, okay.
That's where the async sampling got in. This was like, how many years ago now? 8 years ago, there were these discussions about async sampling, how that is the solution to everything. And indeed, that was a very good solution to say how can we profile code without adding this overhead, without having this global save point that we need to stop all threads in. And yeah, we support that as well. We have async sampling in JProfiler. We have you can choose, but it has its own trade-offs. It's not that you can say this is better in every respect. This is better in this respect, and in other respects, it's worse. It's you have to do that, as I said, in a signal handler. So you basically tell the operating system to call this piece of code that you have on a signal handler. But in the signal handler, you can't do anything really. You can't allocate memory. You can't work with a JVM. You can't like call the JNI or something like that. Everything is impossible. So you have to write that in a very restricted way, and there's lots of features that you cannot support with async sampling. And so if you use async sampling in JProfiler, then the total set of features that JProfiler offers is very much restricted. So and it's not because we're lazy to implement it, but it's because it's not possible.
That's very good. So JProfiler supports both, right?
Yes.
So the first kind of a profiler is called instrument. How to call it properly?
Instrumentation. Yeah.
Instrumentation. Just instrumentation, and there is a sampling or sampling profiler and instrumenting profiler and sampling profiler. Maybe this is the right? So there are two kinds of profilers.
Yes, it's just a mode. Like when you start a profiling session, you can then choose which of those profiling modes you want to use. The views that you see are always the same. So,
but what we learned is that the instrumenting profiler is also asynchronous, right? It is not completely synchronous because something like a stop the world checkpoints are no more possible because of the overhead. So the instrumenting profiler is also asynchronous, right?
Right. I mean, you don't have that global save point thing with instrumenting profiles because you just collect the data. It's in the code. Yeah.
Okay. So how the instrumenting profiler is working. So I'm using the JVMTI and say, hey, look, I would like to intercept these calls, and if they call you sample the data, right? This is like AOP, aspect-oriented programming, more or less.
Yeah, actually, you modify the bytecode. So when the class when the JVM loads a class, you have a hook where you can say before you actually load the class, give me the bytecode, and then I give you back a modified version, and you load that.
Yes.
Then you insert all your insertions basically for profiling. You say, like, for example, when the method is entered and when the method is exit, please call me, and then you can measure the time. So, and there's lots of detailed problems then how you do that efficiently, and you have to take care of many things if you want to modify existing bytecode. But that's the way you do it. And if you do that too often, then the program will slow down a lot, especially because you have to report the data that you collect down to the native layer. You have to make JNI calls there. It's also expensive. And because you insert code into methods that really don't do anything and would be inlined by the hotspot compiler if it were not for your insertions. So you're changing also the way the JVM runs. It's in a way that is not ideal. So there is trade-offs everywhere. Like all of these profiling methods for collecting method calls have their benefits and their positive sides and their negative sides. And you cannot find one which is always the best. This is impossible. So you always think about it, what is it for my application, for my use case that is ideal. And it can be instrumentation. It is often instrumentation where you say, yeah, it's just I have these very high level classes that there's just a few of these methods that I need to instrument, and I don't instrument the XML parser. Like that's not good. You should not instrument an XML parser in with all its methods, because that will not produce good results for the call tree. But if you have like your string beans and so on, you can instrument that. They're not called very often, and you will get very accurate results that way with lower.
And why the Java agent is now slower? Because the Java agent also instruments the bytecode. I think the instrumentation is slower, but if it's instrumented, it could be as fast as the native one, right?
Yeah, absolutely. It will produce the same. It can produce the same instrumentation, and the Java agent also has this hook where it says exactly, like, give me the bytecode before you load it. I'll change it, and then you can load it. And of course, the Java agent has to have some instrumentation library that is in Java, and those are available. We do all of this in the native part, but the end result will be the same. You're absolutely right. So you can write.
The loading is slower, maybe, right? So the initial startup is slower with Java agent, I guess. But if it runs, it could be as fast as a native compiler, right?
As for an instrumenting profiler, absolutely. Yeah.
Okay.
But for the sampling stuff, you cannot really do that very well with a Java agent. You would have to resort to this brute force thread inspection with Java methods, which is not suitable for real profiling.
Yeah. So what we learned instrumenting is that we modifying the bytecode to implement hooks, and the hooks are called, and we have to be smart where we put the hooks. But if the hooks are there, they are gathering data. What I didn't understood is you told me that the data has to be passed to JVM layer. I could also pass the data to Java layer, but I know it's hard, right? I will need something outside. But in theory, I could modify the bytecode. I would say, just this is ridiculous, but I could even call, an external interface, right? To pass the data from the instrumentation. I can do whatever I like, right?
Yes, absolutely. I mean, if you have a Java agent instrumenting profile, of course, you stay in the Java part all the time, and then you accumulate the data there.
But even in the TI case, I could generate bytecode which calls an external interface, right? I mean, this could also work or not.
Well, yes, of course. First, when you instrument, you have to call some Java code, and then that Java code decides what to do
exactly.
with the measured data. That is how it works. Yeah?
But you decided to call native code, right, from there?
Yes, because we have many other data collection operations which have to work in the native part, and that's where all the data is stored and then passed on through the socket to the JProfiler UI. That's
okay.
The way out for all the data. It's not like we can push the data up into the Java space and then work with it from there, but we go into the native part, and then from there we either write it to disk or we communicate with the JProfiler UI. That's how it works. But of course, you can have different design decisions, and they will have different.
That was interesting to chat with. I never built a profiler, but it's interesting to architectural decisions. For me, looks like a big data project. I spend lots of time in enterprise, so we would have Kafka and data collection, but the architecture will be similar. So we have IoT or whatever, which produces lots of data. Then with a queue, let's say Kafka on the other hand, we would just try, to make sense what's in the streams or topics and aggregate them. And so this is why I'm asking, because it is you are on the micro level and I'm on the macro level, but it's very, very similar design decisions, right? How often it has to be called, what is remote, what is local. So this is why it's so interesting.
And then, of course, this async profiling was for a time where you said this is when you have CPU bound code, you have to do that, and you have to put up with the drawbacks that it.
But what is the difference? I mean, there is no instrumentation, right, with async profiler in place.
It's like sampling, but not with the JVMTI methods, but with this unsupported experimental hotspot interface. There's various ways even how to do it, but this is the thing. There's a guy from SAP, Johannes Bechberger, who's trying to get this formalized and produce a supported version of the async get stack trace method, which is this experimental hotspot API. A sort of version 2 that is then like an official part of the JVM. And that is very interesting. We would be happy to see that. But there is a tension between the core JVM developers and this idea, because they don't really like it. They sort of think that JFR should be like the JVM profiler, and that is their main interest. But I mean, JFR can be seen as a profiler in some sense, and it produces the data that a profiler would visualize. But fundamentally, it's a logging tool. So it logs data, it logs events to a stream, And I'm not sure. It would have to gain additional capabilities to be a real profiler. We would actually like that because we do fully support JFR. JProfiler has a lot of support for JFR. You can work with JFR, with JProfiler attached to JVMs and so on. So it's one of our data sources, basically.
By the way, could you use JProfiler for custom JVM, so business JFR events? If I create my business events and use just JProfiler as a nice view for it?
Yeah, absolutely. You should use JProfiler for anything that you do with JFR. You can attach to these to JVMs. You can start recording. If you look, that is what we did in the last release, JProfiler 14. There was lots of additional JFR support, and you can analyze JFR snapshots. You can open JFR snapshots and analyze it with JProfiler.
This is great. This is almost like a replacement or a better version of mission control, right? JMC.
Yeah, absolutely. You should see that as a replacement for mission control.
You have somehow been more visible, Ingo. So this is what I didn't thought about. I always use Java mission control, and using JProfiler as a nicer view is actually a great idea. For me, it didn't occur that actually you could use JProfiler this way. So it's actually great because it's always good to have alternatives, and JFR is particularly interesting for on-premise projects where you can have your own business events for monitoring. Having a nicer view is always nice, right?
Yeah, and we thought about it also in the context that the JVM developers are planning to disallow attaching native agents to running JVMs by default. You have to put a JVM parameter, VM parameter to allow that. That is probably coming at some point in the future. So, you will have these running JVMs where you will not be able to attach, because this will not be allowed. And so, having JFR, which will always work, if you have that available as a module in the JDK that you're using for running the application, then that is a fallback option. Where you say, at least I have that. It's not ideal, but it's at least something. You can get some insight with JVR data. I'm not talking about the custom events, of course. That is the particular strength of JVR, but also for finding a particularly pronounced hotspot or getting some idea about object allocations, and you could use JFR to do that.
One brief question: if you would like to, for instance, introspect the heap or just memory consumption, JVMTI is the same interface, right? So you could access via JVMTI to find out, how big our object is or something like this.
Yes, and with JVMTI, you have allocation sampling, where you can say do not report every allocation, because that is expensive. If you say report every allocation to me, and I will then create some data, that is very expensive, because the JVM makes a lot of allocations, and you don't typically you would say do not give me every allocation but every 100th or something like that. And then you build something from that where you can get a statistical idea of what's happening. So that's a feature that's baked into the JVMTI that allows you to get information on how much is allocated and where it is allocated and what objects are allocated. So that's also in the native interface that is possible to do that in an efficient way.
So back to async profilers. I think the first I can remember, or the first profiler can do both. I don't know whether the first, but the classic one was JVisualVM, right? It instrumented, but you could, the first time I saw it, actually use sampling to have some idea. And the sampling was almost free, but data could get lost, right? It sampled, I think you can even set up the sampling every 200 milliseconds, 1 second or whatever. And it sampled, and then it compared the stack traces, but the data in between could get lost. So those the simplest possible sampling profiler, right? JVisualVM.
Well, I mean, it uses the same principle as any sampling profiler.
Still, was the hotspot hack with the internal?
No. That doesn't use async profiling. Okay. It uses JVMTI sampling. But sampling is always, you say every 10 milliseconds or so, call my callback, and I will inspect the stack traces. Of course, what's happening in between you don't know. Exactly. So you always build between from one moment to the other. You build an idea what's the common stack trace of these both these stack traces, and I'll take that. And that's just the way sampling works. You don't have invocation counts. You don't know how often a method has been invoked, which may be very important. You may really want to know, like, this has been invoked a million times, or you can't say. It could be once, it could be a million.
So this is the first true drawback, right? So this is the first what an async profiler cannot do. Counters.
What sampling cannot do. There's no difference between sampling and async.
I mean sampling. Sampling, yeah.
Mm-hmm. So you need instrumentation if you want to know how often something has been called. That's definitely the case. And there's other things that you need instrumentation for. For example, we have a feature which is called exceptional method run recording, which is if you have, for example, a service that has to complete in a few milliseconds, and it's called very often externally. And sometimes it takes not a few milliseconds, but a few hundred milliseconds. And you really want to know, like, once in a while, when that happens, what is the cause of that? I want to see the call tree for that one exceptional invocation where it took a long time. And usually with a profiler, it's not possible. I mean, how do you get that one invocation when it's drowned out by all that fast invocations, which are very many? So you need instrumentation to do that, and then you can have this special feature which can then say, okay, the slowest, I present to you here the slowest 10 invocations of that method with their separated call stacks, call trees. And then you can look into that, and then you see that one SQL statement which took a long time. You say, okay, this is this, and you can find out what the problem was there. So these are types of features that that need instrumentation. So if you're a purely sampling-based profile, don't offer instrumentation at all. There are certain features that you cannot offer.
Exactly. So the sampling profiler can only observe the world, and then do some calculations between snapshots, basically, yes. Right? This is only an sampling profiler can do. But you're right. The instrumenting profiler, what you can do, you can inject like smart hooks, right? So I can have some basic logic inside, say, okay, call me only if it takes longer than, let's say, 100 milliseconds. Or you can even say, please report exceptions, right? So every exception with specific type, I would like to have a exception counter.
That's what, for example, that's what a probe is, basically, when in our terminology. So JProfiler has lots of these probes, which are all instrumentation-based. We inject somewhere into some framework code, into some code in the JVM and intercept stuff there, and then we build data for our probes. And one of those probes is, as you said, the exception probe. So you can start exception probe recording. This is all optional, of course. We cannot record this data all the time. It depends on what you're interested in. But if you start that exception probe recording, then it will show you where exceptions have occurred, what call stacks they have, even hotspots of the exceptions. They can find where these exceptions are generated. So there are all these high-level probes that rely on instrumentation to produce data.
So smart data gatherers are called probes, right? It's like data gatherers with additional logic.
Yeah, it could be a description for that. Yeah, it's they collecting data from known frameworks
on condition or
like Hibernate, for example. You want to know when you're working with Hibernate what the various operations are and how long they're taking, and you want to correlate that with your call tree. So when you have the call tree of your application, you would like to see the Hibernate operations in there.
So they know what Hibernate is. So it just gathers data from Hibernate packages, right? So this particular probe would do, right? So it's smart about gathering data.
Yes.
Pre-filtering. Yes. Interesting. So let's say, do you have many, not framework specific, but just Java SE probes? Like, we talk about timeout, or exceptions, I can imagine, exception counter, timeout maybe. What else?
Yeah, there's sockets and files, for example, which is like this I/O stuff. The standard I/O stuff that you have is in the JVM SE. Then, of course, like the I/O stuff expands to stuff that is not directly in Java SE, like HTTP clients, for example, and databases as well, which is like I/O. related probes, and those are actually really important because like the usual application has performance problems with I/O bound code. It's always it's not the CPU bound stuff is a lower percentage of the problems than the I/O bound stuff, and so
this is what I thought about if you mentioned the probes, because I thought what I will do, let's say I'm working a lot with application servers, let's say. So okay, if something is slow, only escalate this method if, let's say, the I/O was also slow. You can say, okay, if the I/O is slow, I know that there's something wrong with the network, but not necessarily with the method. So, and if the method is slow, then it's the question why it's slow. Is it slow because of the network? And if you see in the stack trace that you have some logic in the class which calls several I/O actually backend services, so I could provide some smarter pre-gathering, almost like alerting. I could actually use the profiler, to see what's going on in pre-production test or whatever, to see whether it behaves properly, right? An application.
Yeah, the way it works in JProfiler is that you have thread states. So the call tree is not like just one call tree which tells you the wall clock time, which would be pretty useless actually. So it has these various thread states where you can say, was the thread actually running, which we call the runnable thread states. Then you have the waiting, the blocking, and the net I/O. So you can just switch. You have this selector at the top where you say, just show me the I/O bound call tree, where only I/O methods are important.
This is like JVisual VM had the same, right? It was like a stack trace view where I can switch between the states. You remember this, JVisual VM?
Yes, absolutely. You need that, but it's for waiting and blocking only. This net I/O stuff, that's something that you have in JProfiler.
Okay. So
which also uses instrumentation, by the way. We go into all the various low-level stuff in the Neo thing, and so there's lots of knowledge about how the JVM operates that we need to do there to gather this thread state information for the profiler.
Okay, then the sampling profiler, they cannot be probes, right? I mean, they have to work without probes. They have to be smart from outside. They can only...
We have this hybrid, of course. We always do instrumentation. There's always instrumentation, for example, for these things, for knowing when we are in a net I/O state. That is correlated with this sampling. So we know from instrumentation, now this thread is in an I/O state. And when we sample, we know that, and we correlate that, those both sources of information. So we do never do purely sampling mode, but there is always some level of instrumentation going on with JProfiler when you work. It's just that it's all very high level and it never goes into your application call.
But the pure sampling profilers, like the async profilers, they don't have any probes, right?
No, they're not probe based. They're purely about let's measure the call stacks, the call tree, and the hotspots without disturbing the JVM. But this, JProfiler is more like this enterprise tool where you work with real applications and have real problems, and not. It depends. I mean, if various developers have various problems. If you're a JVM developer, if you work on the JVM, then you have very, very different problems in terms of performance than somebody who works on a Spring Boot application. So they need totally different tools. And the JFR, for example, that's a tool that the JVM developers wrote for themselves to make the JVM better. Yeah. And it turned out that it's interesting for other people as well, but it's the fundamental DNA is let's solve our problems here for making the JVM faster. But that doesn't translate to people who are working on enterprise applications. They need something else.
I'm just trying to find use cases for me using the async profiler, because I'm mostly interested in probes, instrumenting. This is what always was interesting. And I only fall back to sampling profiler because sometimes, the instrumenting profilers like JVisual VM sometimes was really slow. So this JVisual VM, it started and instrumented, my servers. Sometimes it took 5 minutes to instrument. And with sampling, I got a rough estimation. Where is the hotspot? So I use also both, back then, I remember, it was 10, 15 years ago. So it was JVisual VM, and then I thought, okay, let's start, the full mode, and it took forever. It slowed down the application, and I was glad that timeouts didn't happen, with the backend. Yeah, and then I used sampling. I was okay. Now I have a rough idea, or just went through back and forth. But I never used the sampling profiler advantage. I just always use it for speed, right? But I played with JProfiler, and I think I used the instrumentation mode because there were all features available, and it was crazy fast. So if the instrumentation is fast, now the question is why we should ever use async profiler.
Well, async profiling, you should use that. There is, as I said in the last podcast, like with Java 17 Plus and JProfiler, there is a lot less use cases for async profiling.
Yeah.
Because the normal sampling doesn't have the global save point thing anymore. It just has a per thread save point. And so you could use async profiling if you're worried about the per thread save point bias. So what that means is that the hotspots that you see might get pushed up in the stack trace and so on. So you're not really having an entirely accurate picture of where the hotspots are. But I personally think that you have to construct use cases for that. So you have these example programs where you can see how this is happening. But these are all methods that don't do anything or just spin a little around. So this is not real programs. And the differences are very little. They used to.
So I think what I can imagine, if you have really high performance, you're building a high performance app, something, and you say, okay, I don't trust the instrumentation method, so maybe you can use async profiler, so you got to sure nothing is instrumented, it behaves as it should, right? It's just observation from outside. And then if you see, you say, okay, then I know what it's doing, then you could use because this is what I can imagine, that this is almost, the async profiler is almost like, without the Heisenberg, right? So because you are looking from outside, so you are pretty sure that there is nothing to disturb, yes. Because of course there's a little overhead, but there is no instrumentation in place. You're just observing with a little interaction with the program as possible, right?
Yes, and it's all sometimes really good to have multiple methods to look at the same thing. So you look at with normal sampling, you look at it with async sampling, you see, does that produce the same result basically? Yeah, mm-hmm. and if that's the case, then you can stick with normal sampling, because it has more features and is generally better than async sampling. Just if the single thread save point bias is not an important factor for you. So if you're writing a multi-threaded compiler or something, and you want to get really precise information on how the time is spent in the various subsystems and so on, then you should use async profiling.
Or what I think also their project, the pattern called Disruptor, like a ring buffer, high performance ring buffer was used, I think, for Log4j2. Like they can do millions of transactions per second, along with byte arrays. I think in such a project, maybe you have to do both, because it's the overhead is, maybe even in this particular project, I'm really interested how the hotspot optimizes the code without the probes, so you can be pretty sure it behaves as it should, right? Or
yes,
as it has.
Yes,
this may be the extreme projects, but for enterprise, I would say, for me, instrumentation was always the way to go, and then only fall back to sampling because of performance, because sometimes the instrumenting profilers were not usable, right? And as I told you, my experience was C-Tracker back then was also slow, as I remember, with the instrumentation. JVisualVM was also slow, and the breakthrough was the Java Mission Control. With it was not exactly a profiler, but it was good enough for me, to find memo leaks or resource leaks. This is what I use the Java Mission Control for. But now it's cool. So we have a commercial option for Java Mission Control, which is really, I really appreciate. So I will take a look on that with JFR and JProp.
Yeah, absolutely do. Yeah, appreciate feedback. If you think yes.
I was last week at a conference called JDD in Krakow, and before my session, which was just fun, I just like Java snippets session. But someone asked me what's my opinion on Kotlin. No kidding. And I told my opinion is that there is no reason for Kotlin, because I'm using Java 21 and this is just good enough. So maybe Kotlin is like syntactic sugar, but I don't think with Kotlin I will be faster or more productive more than 10%, and then it's not worth. And what I said is that I will have a podcast with the JProfiler, and he will convince me why Kotlin is better for Java for particular use cases. The problem we have is this podcast is already getting too long. So my suggestion would be one session, if you have time in future, just about Kotlin. What do you think? Otherwise, we will, because this is a great topic about. I think we nailed instrumenting versus sampling, right? There's nothing more to add. Or do you have something which could be, clarified with the profiling space?
No, I think we talked a lot about the various modes, and it's really important, and it's difficult and tedious for people who want to profile to think about these things, because they say, why doesn't the profiler just record the data and show it to me? Why do I have to think about these things and the trade-offs and so on? But you have to, because there is no best way. And that's just the reality of it. And
which is good. This is why we have jobs, right? If there will be just only one, then
absolutely. Yeah.
And by the way, I met Mr. Bechberger in Devox, and we had a chat. He had a talk about building Profiler in 30 minutes or something. So it's a really nice, interesting talk how to, with flame charts and stuff like that. And I will have him on the podcast as well. So we'll talk about his take on that.
Oh,
so
that's interesting. Yeah, because I really like what he's doing, and I would be very happy to get that in the JVM. And I'm a little skeptical, like when I read the mailing lists and so on. It's they have their own ideas, and I'm not sure if they will do that. And they're very much focused on their world, not so much about the outer world.
But this is always the case. So I work but this is. I mean, but this is always the case, right?
Yes, of course. I mean,
I worked with Sun Microsystems back then, or not with. They produce application servers like Glassfish, and I used the application servers. So sometimes I couldn't understand the engineers, because they look at Glassfish from complete different perspective than I did from outside, right? For instance, they were concerned about modularization of the entire thing. And I didn't care. I just wanted that it boot fast. Whether there's one module or 50, I say I really don't care how many modules do you have internally. I would just run the thing and put my application on it and call it a day. So there was for me, and I think it's the same in the JVM. They would probably have the fastest, safest JVM on earth, and we Java developers would like to have a JVM which is easy to use. With not just connect and do something, and not to be. This is maybe the tension, but this is normal. I think it's the same with you as a product builder. You have a complete different perspective on your product than I from outside. So this is normal.
The same with the module system in the JVM. That was, I think, a great controversy. I mean, lots of people ask, why are you not doing something? We need these features from OSGI, and so
exactly.
Your module system doesn't do any of that, and what does that? What benefits do we have there? And that was a module system really for the JVM, and they solve their own problems and some problems of developers, but maybe not enough to warrant the disruption. So that was a controversial thing. I think that now it's in the past, and that's
the interesting part. I didn't like OSGI. So, and what I did, I said, okay, we will not use OSGI in my project, because module system will come out. And then what I knew is, if the module system will come out, maybe the project is over, no one cares. And now we have the module system, and we not use the modules a lot in enterprise projects. So I use it more in CLIs or whatever in my own leisure, but never in microservices, because the microservice itself is a module, right? So we don't need more modules inside a module.
Yeah,
so
it's monolithic application.
Yeah, exactly. Ingo, perfect. So the next time we'll talk just about Kotlin. Maybe a little bit profilers. Maybe even a little bit Kotlin profilers could be interesting.
Yes,
but I will focus.
Yeah, that's
focus. Why Kotlin is better than Java. This will be the title of the podcast. To be a little bit more controversial.
Okay. Let's do that. I'm looking forward to it.
Oh, maybe where people can find, JProfiler, your technology page. This is a little bit promotion. I forgot about that. So EJ Technologies, right?
EJ Technologies. But you can just put JProfiler into Google, and it will get you there.
Okay. Thank you.
Easy. Thanks a lot, and I'm looking very much forward to talking to you next time.